Hello and welcome back to tutorial number 4 in this lecture series on syllogism. We have already discussed the basics of syllogisms and Venn diagrams, how to make minimum overlap Venn diagrams, and to solve problems involving affirmative conclusions using the minimum overlap diagrams. Now in this tutorial, I'll tell you how to deal with questions that involve negative conclusions. So if you haven't watched the last 3 tutorials, my advice for you would be to watch them first and then come back to this one. Alright, let's go to the question now. This is your problem. Again, very similar in structure to what we did last time. So the first step again would be the same, to draw the minimum overlap Venn diagram. Let's go to the statements now. 1. Some melons are kiwis. So let's draw melons and now kiwis. Okay, statement 2. All grapes are plums. So let's draw grapes separately and now plums. Number 3. All kiwis are apples. So let's draw apples like this. And number 4. No apples are grapes. So let's make something like this. It tells us that whatever else we do with this figure, we can never make apples and grapes overlap. So this was pretty simple. This was exactly what we did last time. I hope you would already have understood minimum overlap diagrams and now you can draw them comfortably. That's critical. So let's go to the conclusions now. 1. Some apples are melons. We can clearly see from the diagram that some apples are melons. So this is fine, it follows. Number 2. Some grapes are kiwis. We can see from the figure that kiwis and grapes aren't overlapping, nor can they, because grapes and apples are disjoint sets and kiwis are contained completely within apples. So this does not follow. Number 3. No apples are plums. Now this is the negative statement that we were talking about. If you look at the figure, apples and plums are shown to be disjoint sets. But please remember that this is just the minimum overlap diagram, which tells us only about the necessary conditions and does not explore the possibilities. So now when we have a negative statement there, we have to look at the possibilities as well. That is the only difference between dealing with affirmative statements and negative statements. For affirmative statements, you can answer directly from the figure. In case of negative statements, though you can answer directly from the figure, you will have to visualize the possibilities as well, as in the case of this conclusion. Now according to this one, apples and plums are disjoint sets. So we'll have to look for the possibility of apples and plums overlapping. Now to see how it works, just look at the conditions for plums. The only condition given is in statement 2, which says that all grapes are plums. This is it. So as long as we are not violating this condition, we can do anything with plums. For instance, something like this. Now look at this new figure. Does anything change here? Not really. Look at the statements once again. Some melons are kiwis? Yes. All grapes are plums? All grapes are still plums. Number 3. All kiwis are apples? Yes, all kiwis are still apples. And number 4. No apples are grapes? Yes, apples and grapes are still disjoint sets. So basically nothing changes. But what this new figure tells you is that apples and plums are not necessarily disjoint sets. So they can be an intersection between apples and plums as well. So it means that conclusion 3, no apples are plums, does not follow. It's not necessarily true. I hope this is understood. Let's go back to our original figure. I would want to mention one thing here. You would only need to make this one figure in the examination hall. So you would never make the figure that I just showed you. That was just to explain to you what I am doing with this figure. You should only visualize that one. So the figure that's there on the screen is the all important figure. Just this one and nothing else. Just do that expansion and manipulation mentally and answer the question. Look at the next conclusion. 4. No melons are grapes. Look at melons. Since some melons are kiwis and kiwis are contained within apples and apples are disjoint sets with grapes, there are some melons that can never be grapes. We know that. But look at this portion of melons. The one with these marks. Is there any restriction on this portion? Absolutely not. They can be anything. They can be grapes as well. Yes, why not? If it's difficult visualizing because of the relative placement of grapes and melons, I'll draw this figure just once for you. Look at this. There we are. We can see melons and grapes intersecting now. But first check if we have violated any condition. The only condition on melons in the statements is given in statement 1, which says that some melons are kiwis. Apart from that, there is no condition on melons. And you can see that some melons are still kiwis. There's an intersection with kiwis. So that still holds. So that means that we are not violating any condition given in the statements. And since we can see that an intersection between melons and grapes is possible, we cannot conclude that no melons are grapes. That's just a possibility, but not a definitive conclusion. So it means that it does not follow. I hope this is understood. This is very important. The reason is that you will not have to draw this diagram again and again in the examination hall. Just one minimum overlap diagram and then you should be able to visualize it. Simple. So our answer to this problem would be option A. Only one follows. Let's look at the next example to understand the concept better. Again, similar structure. Let's look at the statement straight away. At least some trams are autos. Let's draw autos first. And now trams. All trams are cycles. So let's draw cycles. All cycles are trucks. So let's draw trucks now. Alright. Number 4. No trains are cycles. So let's draw trains separately and do something like this. It shows that cycles and trains are disjoint sets. You should always remember the purpose of drawing these Venn diagrams. There is just one purpose. If you draw this, you should be able to tell visually whatever is written in the statements. This is it. So it becomes easier for us to process the information. Look at the conclusions now. Number 1. Some trucks are autos. Yes, we can see the overlap, so it follows. Number 2. No trams are trains. So it's a negative statement and we'll have to look at all the possible cases. But if you look at the figure, we can see that cycles and trains are disjoint sets. So there can be no overlap. And all the trams are contained within cycles. So there can be no tram that's not a cycle. So it means that if cycles and trains are disjoint sets, trams and trains would also be disjoint sets. That's easy to understand. So it means that no trams can be trains. So it follows. Number 3. No trains are autos. Now as we can see from the figure, trains just have a problem with cycles. Otherwise there is no other condition. In fact, trains does not appear in the set of statements apart from statement 4. So that part of autos that are common with trams and therefore cycles cannot be trains, for sure. But there is this part of autos as well, the one with marks. There is no condition on this part. So this definitely can be trains. Now this is very similar to what we saw in the last example. We can clearly see that this region of autos marked with these crosses is free to be trains. I'll not draw the figure for this one. Visualize this. So this conclusion does not follow. Number 4. Some trains are not trucks. If you look at this figure, trains and trucks are shown to be disjoint sets. But is there a condition like this? No. Trains just cannot intersect with cycles. Otherwise, there is no other condition. So all the trains can be trucks as well. Yes, that's possible without even touching cycles. Something like this. Now, does that violate any condition? No, absolutely not. Trains and cycles are still disjoint sets. But now all the trains are within trucks. It means that our conclusion, some trains are not trucks, does not follow. All the trains can be trucks. And so our answer would be option B. Only 1 and 2 follow. I hope this is understood. Though this question looks lengthy and with a lot of information, if you do it properly, methodically, it should not take more than 30-40 seconds to do. But your concepts should be absolutely clear. Let's look at one last example for today. Let's start by making the minimum overlap diagram. 1. Some pens are tables. So let's draw pens first. And now tables. 2. All pens are desks. So this is desks. 3. All tables are chairs. So this is chairs. Alright. Number 4. At least some papers are chairs. So this is same as saying some papers are chairs. So let's show papers. Partial overlap with chairs. Okay, so this is the diagram. Look at the conclusions now. 1. Some papers are desks. It does not follow. We can see from the figure. 2. No papers are tables. We can very clearly see from the figure that papers can be tables. The only condition on papers is given in statement 4, that some papers are chairs. So without violating it, we can do something like this. So papers are still chairs, but papers are now intersecting with tables. So it means that conclusion 2 does not follow. It's not necessarily true. So this is the reason why we did all those possible cases of all the 4 types of statements used in syllogisms. Some papers or chairs can be drawn like this as well. So this is one of the 4 possible cases. I hope you remember that. Alright, let's bring papers back to its position. This is important. Whenever you start thinking about a conclusion, start from the minimum overlap diagram. In fact, as I keep repeating myself, don't draw anything apart from this. Try to answer it mentally. Okay, conclusion 3. Some desks are not chairs. Now, what is the condition given on chairs? There are two, statement 3 and statement 4. 3 says all tables are chairs, and 4 says some papers are chairs. So, if we do not violate these two conditions, we can do anything with chairs. So, that anything can mean something like this as well. Now, all tables are still chairs, and some papers are still chairs. So both are still true, statement 3 and statement 4. They still hold good. But what has happened in the process is that now we can see that all desks are chairs, which means that this conclusion 3 is not necessarily true. So it does not follow. All the desks can be chairs. So that's a possibility, that's a case. Alright, let's bring the figure back to its original position. Number 4. Some desks are not papers. So this is very similar to conclusion 3. But now in place of chairs, we'll have to think about papers. What is the condition given on papers? Just one. In statement 4, that some papers are chairs. So we can see that we can put all the desks inside papers without violating this condition. You should be able to see that, especially after dealing with conclusion 3. Yes, you definitely can. Alright, let me draw it for you. So this is it. So you can see that some papers are still chairs, but now all the desks are papers. So that's a possibility. It means conclusion 4, some desks are not papers, is not necessarily true. So it means it does not follow. And our answer would be option E. So this is where we wind up today. I'm sure you could follow it very easily. So start practicing with negative conclusions now. In our next tutorial, I'll deal with possibility cases and conclusions. We'll see you soon. Take care.